Hi everyone. Today we'll show three MCQ questions from Old Course. You see, question number 5. Every composite number that is can be expressed as a product of uh, what you have to find. So as you know from fundamental theorem of arithmetics, every composite number can be expressed or factorized as a product of its prime. You know that. And as for examples, if you give an example of 4, this is the smallest composite number. You know, composite number, a number which is more than 2 factors, that is all called composite number. If you split it up, you get 2 into 2, that is 2 square. And if you split 6, you get 2 into 3. So these are the prime factors. That means every composite numbers we can factorize into its prime. Yeah, that means this factorization is unique, but in order it may be different. Clear? So that means we can write 2 into 3 or 3 into 2. So that means in which the orders it varies. So it depends on the number. Anyway, so from fundamental theorem of arithmetic we have learned that every composite number can be factorized as a product of its prime. So that means this option will be your answer, primes. Clear? Now, if two positive integers p and q can be expressed as this, p is equal to a square b cube, q is equal to ab, then what is the LCM of a, p and q? And this a and b being prime numbers, as we have seen in the previous number, composite number, we can split into its prime numbers. Now, suppose in LCM, suppose if you find LCM of 2 and 4, what is the LCM of 2 and 4? We assume that is 4 as the LCM. Clear? We have done the LCM, how to do that is, I'm not going to teach you know how to find this LCM. So LCM of 2 and 4 is 4. If this number is divisible by the smaller one and this number is itself is divisible by this number, then we can say that 4 is the LCM. Now you see here, sorry for interrupting this. Okay, anyway, sorry for interrupting. Now, one thing is that LCM of this 2 and 4 is 4. So like that, here, when we find out the LCM of a square, a and a, will find out the LCM will be these two number will be a square, the bigger one. And when you will find out the LCM of b cube and b, here b cube and b, the LCM also will be b cube. Now you see the LCM of these two number, I mean p and q, a square and b cube, and a and b, what would be the LCM? Obviously a square b cube in multiple forms. Now you have to see whether this option is present here among this option or not. This is present in option number C, so you have to write that. Now again, our next question, the decimal expansion of a rational number is always what? Now rational number, you see, we write it in the form of p by q, where this p and q are integers, you know, and the condition is that q must not be equal to 0, that is q is not equal to 0. Now this rational number, I'm giving one example, so 2 by 5. So 2 by 5, if you just divide, you will get 0.4. So this is a terminating decimal number. It is never, that means there is no more number after this 4, clear, except 0. Now if you divide this 1 by 3, then you will get 0.33. Now how to divide that, you know, all of you are just well mastered with that. Anyway, so that one, you know, this 3 is, that means repeating but non-terminating, it's never finishing but repeating. So 2 by 5 is a rational number and 1 by 3 is a rational number. So that one we can either convert it into a terminating decimal or non-terminating repeating decimal. Just in real numbers, you have done that in class 9 also, but in class 10 is also there, so that's why you have to know that. And one thing, remember, if we get the denominator of any rational number in the form of 2 to the power m and 5 to the power n, where these 5 m and n are positive natural numbers, I mean natural numbers are positive, all positive integers, then we can say that those rational numbers will be your terminating decimals. Other than this, if it is not satisfied with that, then we consider that rational number is non-terminating repeating decimal. So rational number is always either a terminating decimal number or a non-terminating repeating decimal number. So that's why, as per your this concept, so we know that means the decimal expansion of a rational number will be terminating or non-terminating repeated decimal. So here this option number C will be your answer. So today I have shown you only 3 MCQ. So on the next video I'll show you a few more, so you learn up to this much. And in the last video you have seen I have shown you 4 MCQ questions. I think all of you have learned that. So for today we'll leave it up to this much. Bye.